Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 15 of the November Daily LeetCode Challenge, and at the starting I just want to congratulate everyone who have maintained their pace till here, because today this is the day 15. That means we are going to complete almost half the challenge. Okay, for the November Daily LeetCode Challenge we are about to complete half. Okay, so that is 15 days out of the 30. So yeah, congratulations if you have been till here. It doesn't matter whether you got the answer to all the questions or not, but what matters here is at least you're learning something new if you are spending some time and understanding what the question is trying to teach you. Okay, so that is what it is all about. And coming to today's question, it is again a medium level question. If you see, like, this whole month basically we had only medium level questions, and most of them were initially around the topic of bits. Okay, the bit manipulation topics. Okay, for example, the XOR and or operations. And finally after that we had some array level questions. Okay, today also we had array question. It's again a tricky question, but yeah, this is a good question. There is a lot to explore on this. Okay, there are multiple ways to solve this, and there is a lot to explore, and we will see such approach here. In this video, I will be giving the solution in Java and Python. So let us begin this question. Okay. So it is 1574 shortest subarray to be removed to make array sorted. Okay. The question is very self-explanatory. So it tells what the question is all about. Okay. But still, let us go through it once again. First of all, like, just see what is the input going to be. Okay. You're going to be given an integer array and you have to return an integer output. Okay. Let's see what the question is. Given an integer array ARR, remove a subarray. It can be empty also. That is, you don't have to remove anything. Okay. Just like is a subarray basically means that it can be of zero length also. Okay. That's what they're trying to say. It can be empty from array such that the remaining elements in the array are non-decreasing. So what is a non-decreasing? Non-decreasing basically means either the elements can be same, that is two adjacent elements, they can be same or they can be increasing. Okay, I will show you with examples what it means. But non-decreasing basically means that it should not decrease as we move from left to right. Okay, as we move from left to right, either the elements can be same or they can be increasing, but they should not decrease. Okay, that is what is non-decreasing, right? So return the length of the shortest subarray to remove. Okay, in order to ensure they are non-decreasing, you have to remove a certain subarray. Okay, so you have to return the length of the shortest possible subarray. Okay, that is the answer. A subarray is a contiguous subsequence of the array. So what is a subarray and what is subsequence? I am not going into the detail of that. Multiple times in my videos I've explained the difference between a subarray and subsequence. So I hope you're very clear by now. Even if you have doubt, you can just do a Google search, you will get to know it. Okay, but this question is around this topic of subarray, so I'm not going to spend much time on that. Okay, so coming to this question, if you see here, what is the non-decreasing subarray basically? So if you see here, for example, this part 235. Okay, if you see here, the elements are continuously increasing. Okay, that is 2. For example, this first element is 2, then the next element 3 is greater than 2. Similarly, 5 is greater than 3, and so on. Okay, it can be same also. For example, if you have double 2, okay, let me just start this and show you. Okay, so if we have, for example, 2 and then again a 2. Okay, and again a 2, like this you can keep having. So this is also non-decreasing. Remember when we are going from left to right, at least it is not decreasing, right? That is what is a non-decreasing after all. Okay, that is the non-decreasing. It basically means that either the element should be greater than the previous element or it should be same as the previous element. Okay, as simple as that. That is what is non-decreasing. So I hope you understand that. So now let us come to the particular question. Okay, example 1. We are going to trace this example also. Okay, but just let us see what they are trying to tell here. See here, this is the array given to us. We have to remove a part of it. Okay, so here they are claiming that this particular part can be removed. Okay, 1042. So let us see after removing what happens. If we remove this part, if you see the non-highlighted elements, what are they? 1 2 3 3 5. Okay, they are non-decreasing. If you see here, 3 is repeating, but that is fine. Okay, when we move from left to right, okay, either the element should be greater than its previous element or it should be equal to its previous element. So it is perfectly fine. Okay, 1 2 double 3 5 is fine. So what array they are asking us to remove? They are asking to remove 10 4 and 2. So what is the length of this subarray? It is 3. So the answer is going to be 3. They are claiming it is the minimum possible. Okay, that is what they are claiming. Okay, see, there are multiple ways to do that. It need not be only 10 4 2. There are other ways also. You can explore that. Sorry, yeah, 10 4 to this part. There are other ways as well. You can go for that also. Okay, for example, if I take 3 10 and 4. Okay, even then it will be same. We'll get the answer same, but yeah, the array to be removed is slightly different here. Okay, so here the emphasis not on what is going to remain or what is going to be taken out. Here the emphasis on the length of the subarray that is going to be taken out. Okay, that is the first thing. So there are some other good examples also. If you see here in this case, okay, this array is not increasing at all. Okay, this array is not at all increasing. It is basically decreasing. So the idea here is, even if you remove something, still it will be decreasing only. So what is so the idea here is, at least you have to remove 4 elements and we can leave any one element here. Okay, either I can leave the 1 or I can remove this subarray and leave the 5. Anything you can do. Okay, either you can do that. So answer is going to be 4, because we have to at least remove 4 elements for it to be non-decreasing, because if there is one element, obviously it won't be non-decreasing, right? Similarly, now see this here. If you see, nothing is everything is perfectly fine at the starting itself. We don't have to remove anything. So the answer is 0 here. Okay, that is the subarray to be removed has length 0. That is fine. Now if you see the this thing here, and it's 10 power 5. So whenever it's 10 power 5, the only thing that you can use is either the O of n approach, that is a linear approach, or O of n log n. Okay. Beyond this, it will be risky to do. Okay, as simple as that. And the values are always going to be positive. There is another good thing to do. Okay. Remember, if the values are negative, then your approach will be changing. Okay. If, for example, if you're doing some comparisons, you will have to consider the negative part as well to do the comparison. Okay. So you have to remember that as well. So in this case, all are going to be positive or zero. So we are good here. Okay. So let us start the example one and the tracing of that. Okay. Let us quickly do that to understand what is happening. So so I have formed two arrays. The idea is very simple. Okay, the idea is going to be very simple. If you see, I've formed two sub arrays. I will tell you what they are, and finally we are going to write this length. Okay, length of the shortest sub array to remove. Okay, let me put enter here. Yeah, length. So what is happening is, just if you try to see the first example, what is happening? See, for example, this is the sub array to be removed. So let us understand this first. Let us fix this sub array to be removed. Okay, 10 4 2, and see what is around it. Okay, if you see the left part of it, there is 1 2 3. That means first there is a rise. Okay, from 1 to 2 to 3 there is a rise again, right? After we remove the sub array, again 3 and 5, there is again a rise. Okay, so what we are trying to tell you is that, if you see, this particular part is actually dividing the answer into two parts. Okay, the left part and the right part. The same is what we are trying to do here. Okay, so what we will do first, from the right I'm going to start. Okay, first I will try to see how long can I form a array from the right itself. Okay, that is, if I start from here. Okay, and if I so I will what I will do, I will ensure that the, let us say, my pointer is at the last element. Okay, n minus 1. Okay, then I will check whether n minus 1 is greater than its previous element or not. If it is greater, this forms a part of my right subarray. Okay, similarly I will keep expanding it. Okay, for example, 2 3 5 is also possible, right? After 2 I have to stop, because the next element, that is 4, is not less than 2, so I have to stop here. Okay, so basically I will stop here. So that's what I'm going to do now. If you see here, 5 I will start. Okay, whether I will check whether the previous element for 5 is less than 5 or not. Okay, it is there, so I will expand that. Okay, now I will check whether 2 is less than 3 or not. It is there, so I will expand it. But yeah, 4 is not less than 3, so I will stop. So my right subarray looks like this: 2, okay, then 3, and then 5. Okay, 2 3 5. Now I will do the same from the start. Okay, I will check whether I will, first element is 1. Okay, then what we'll do, we'll expand it to 2. Okay, I will check whether next element is greater than the current element or not, greater than or equal to, so it is true, then 3, and then 10, and so on. Okay, after that we will stop. Okay, that's what we are going to do now. And also we will see, after each step, what could be the array that we are going to remove. Okay, first, so first of all, since I have found this, okay, so this could be a probable answer. Do you agree with me? See, this is also subarray, right? This basically, this is also array, which is, strictly, that is non-decreasing, right? So the answer here is, I can remove this also, then I can get an answer here. Okay, so the initially, after the exploring the right part, okay, I am exploring only the right part currently. Okay, I'm at this step. So what is that? So this could be one of the answers that I have to remove. That is, this particular subarray that I've highlighted currently could be a subarray that I can remove and get the answer. Okay, so what? But yeah, this not, it did not be the shortest one. Remember that. But still, to be starting that, it is good. Okay, so what is going to be the answer? In this case, the length of this is going to be 5. So I will add 5 here, as simple as that. Okay, fine. Then I will be proceeding further. What I will do, I will take this one here and I will write here. Okay, now my subarray has one right part. Okay, first you will have to write first, see, first element you have to write as it is. Okay, then you have to compare whether is the next element can be part of it or not, and so on. Okay, and so on. So first I am writing it here. Okay, now in order to include this in, for example, see, always the where we ended it. Okay, 2 3 5, this 2 must be, greater than or equal to this. Okay, only then, after removing the middle part, these two can be combined. Okay, remember, we have to combine this and this. Okay, that is, we have to remove the part which is in between them. Okay, the part that's in between them. So in order to ensure that, what I have to do, this particular element should be always less than or equal to the last element here. Okay, you have to ensure that, whether this is true in this case, yeah, this is true in this case. Okay, they are fine. So what is the subarray to be removed now? This forms the subarray to be removed. Okay, here the length is 4 in the first step. So which is minimum, 5 or 4, which is minimum? The minimum is 4. So we will write 4 here. Fine. Now we will expand this window. Okay, whether 2 is greater than 1, yeah, it is 2. So we will include 2 now. I am going to include the 2. Fine. Whether I can merge these two, yeah, I can merge them, because the last element here, okay, is less than or equal to the first element here. I can merge them. Fine. So what is going to be my array, that is the subarray to be removed? It is going to be this. Okay, 3 10 and 4. What is the length of this? This length is going to be 3. So I will write 3 here, because remember, always you have to take the min. Remember, the answer is about the shortest subarray. So whichever length we are getting is the minimum that we have to update here. Okay, for example, if I get 5 in the next step, I will not update, because I already have 3 here. Okay, only the minimum part I have to update. Fine. So yeah, next what I'm taking now 3. Whether 3 is greater than 2 or not, yeah, 3 is greater than 2. So what I have to do, I have to write 3 here. But can I merge these two? No, this cannot be merged. Why? The last element here is not smaller than or equal to the first element here. So what I have to do, I have to remove a element from this. Okay, so I will remove an element from this. Okay, so just let me remove this part. So I have to remove. So now it can be merged. Yeah, it can be merged. So what is the subarray to be removed now? It is like this: 10, 4, and 2. Remember that 10, 4, and 2. Again, the length is 3. So we'll leave it like this. Fine. Next, whether 10 is greater than equal to 3, yes. So I will include 10 also now. Okay. See, first we explored the right part, now we are exploring the left part fully. Okay, fine. Can we merge these two? No, we cannot merge. Why? Because the last element here is not smaller than equal to the first element here. So what we'll do, again we'll have to remove 3. Okay, let us remove 3 first. Fine. Now I have only 5. Now can I merge these two? No, again I cannot merge. Why? Again, this 5, that is the first element here, okay, is not greater than equal to the last element here. So again I have to remove 5 also. Okay, I will remove the 5 also. Now this can be merged. Yeah, this can be merged. Okay, the left part is full, the right one is empty, so it can be merged. So what is the array to be removed? The subarray to be removed, it is this. So what is the length for? So whether 3 is 4 or which is minimum, 3 or 4? Obviously 3. So here the current situation, the answer is coming as 4. There is a length of the subarray to be removed is 4, but we will not consider because already we have an answer of 3. So we have explored every possibility. Okay, first we expanded the whole right part, we explored the whole right part, then we started including the left part also, and accordingly we got to this. So we have currently we have explored all the possible subarrays which can be removed to get a non-decreasing array. Okay, so we are getting the minimum length as 3. So if you see, 3 is going to be the answer here, as simple as that. Okay, so I've done this tracing. Okay, yeah, yeah. So let us now see the code part, what you are doing. Okay, so I've explained how it works. So basically, this is a two-pointer approach. We are maintaining the start and the end, and we are doing that basically. Okay. First, what we are doing, we are exploring the rightmost part. That is how big array we can form such that it is non-decreasing. That is first thing. After that, we are contributing a probable answer. Okay. That is, see, in this case, 2, 3, 5 in the rightmost part, they are forming array which is non-decreasing. Fine. So what in the in the worst case, what we can do, we can remove the whole left part so that we have only 2, 3, 5, right? So this, we are starting our answer with this. Okay, the answer initially is 5. And then what we are doing, we are taking one element from the left and we are trying to integrate them with the right. Okay, so that we are getting the middle part to be removed. Okay, first we try to remove this, then we try to remove this, and so on. Okay, after that we try to remove this, and so on. It happened like that. Okay, and at last we have to remove this whole part. So in between, whatever answers were coming, we were trying to take the minimum out of them, and finally we got 3 here. Okay, so let's see the code now and how it works. Okay, let me run this, and we will see the tracing here, and then we'll go to the code. Okay. So yeah, this is again the first example. Let me quickly go through it. See here what we did. Okay, initially it is okay. See, this is the first example. Okay, okay, this is the case 4. Okay, this is something that I have included on my own. Okay, let me give you, see, example 1 I have already explained. Okay, it remains the same. Let me take you through another case which is going to be very interesting. Okay, I think this is one of the last test cases. Okay, so if you can clear this code test case with your code, then obviously you can clear any test case. Okay, let's see this. So it is 1335. Okay, so initially we start exploring from the right. Okay, what we got, see, from the right we can explore what is the most longest non-decreasing array that we can form. Okay, from the right. So we went from 5, then 3, then 3, and then 1. Okay, then we stopped because the 10 is not less than 1, so we stopped here. So we got this part. Okay, so the idea here is we'll start by answer with this. That is, this is going to be one of our possible arrays, so we can remove this part to get this array. Okay, so the answer is going to start from this. And what is the probable array, a non-decreasing array? This is going to be this. Okay, fine. Now I will decide, divide the things into two. There's the left array and the right array which can be merged. Okay, so what we'll do now, we'll take the first element here, 1. Okay, I took the 1 here. Fine, and I already had this. Okay, whether can I merge these two? Obviously I can merge these two. Okay, so what is the array to be removed? It starts from this 2 till this 10. Okay, so it is 4. Okay, so this subarray length is 4. Our answer will also be 4. By it was previously 5, but I'm getting 4 here. Okay, so I will change it to the minimum, which is 4. Okay, this is the real answer. This is the current step. What is the subarray which we are getting? Okay, that is the one. Next, what we'll do, we'll include this 2 now. Okay, I included this 2 now. Okay, it is now 1 and 2. Now this was my right part in the previous iteration. Okay, but can I merge this and this and this? I cannot merge. Why? See, the rightmost element here is 2, the leftmost element here is 1, so they are not matching. Okay, So what we can do, we have to remove this one, okay? Then 335 will remain. You can see here 335. Now these two can be merged, okay? Now these two can be merged. So what is the element to be removed? It is starting from this 3, okay? This 3 till here, okay? It is again 4. Sub length is again 4. Sub array length is again 4. Answer remains 4 in this step also. Next, what we are going to do? We are going to expand this also, okay? 1 to 3. It became 1, 2, and 3, right? So what we have to do, see, it is remain the same, okay? Here also 3 here. So basically this part, this array and this array can be merged as it is, okay? We don't have to remove anything, okay? So we can merge both of them. So what is the subarray length to be removed? It is starting from this 3 to till here, okay? 3, 10, and 1. So subarray length is 3. Answer is also 3. Next, we are going to expand it. So now we have 1 to double 3, okay? Here 1 to double 3 is there now with us, okay? So what is the previous part? 1, 3, 3, 3, 5. Can we merge these two? Yes, we can merge these two without removing anything from the right part also. Okay. So what is the area to be removed? No, it is 10 and 1. So what is the subarray length? Subarray length is going to be 2. But from the previous answer, whether it's smaller, yes. So answer will be changed to 2 now. Okay, fine. Next, we will expand more. Now we'll go to 1, 2, double 3, 10. So yeah, this becomes 1, 2, double 3, 10. But previously right was this, right? The right subarray was this double 3, 5. But 10 is going to be very high element, okay? With 10 being there, we cannot merge with this. So we have to remove all of this. So the right subarray becomes empty. So now these two can be merged, okay? So what is the subarray length to be removed in this case? Everything right of 10 is to be removed, okay? So 1, double 3, 5 is to be removed. So subarray length to be removed is 4. But we already have an answer which is 2. So minimum we will keep answer is 2. So we are going to return 2 as the answer, and that is the correct one, okay? So this was one of the edge cases, okay? And yeah, this is how the solution works. Let us go through the Python code now. So yeah, if you see here, what we are doing, we are first calculating the length. Then I'm starting the first pointer, okay, which is the end, okay. As I mentioned, first we'll explore from the right how big non-decreasing array that I can form, okay, and equal to n minus 1, okay. Fine. What I'm going to do now, I will run this value. What is the value? This value will run till end is greater than 0. Why greater than 0? You will get to know this by see. What I'm doing for the current end, I'm seeing whether it is greater than its previous element or not. So if you guys guess correctly, if I end is 0, I cannot check this previous element, right? Because there's nothing to it previous of the 0th element. Okay. That's why I've kept end should be greater than 0. And I'm checking whether the current element is greater than its previous element or not. If it is so, I'm doing end is 0 and minus 1. Okay. So at last, let us say in this case, end will come till here. Okay. 2, 3, 5. Okay. So n will be the index of this particular element, okay, 2. Whatever is the index of 2, n will be there, okay, because after that it cannot move. So it will stop there, okay. So what could be one of the answers? The answer here is I can remove this whole part, okay. After, see, this is going to be my end is going to point at 2, and this is the right of it, okay. So this whole area can be removed to get one of the answers, okay. This is one of the rough answers. So we will do as answer is equal to end, okay. That is here, if you see what is the index of it, so 0, 1, 2, 3, 4, 5, okay. This is a 5. If you see, that means basically 5 elements can be removed, okay. That's why answer is equal to end. Next, what I'm going to do, okay, this I did 2 times. Let me delete this part. Yeah, start, I'm again declaring start equal to this is second pointer that I'm going to use, okay. What I have to do, till start is less than end, okay. Why I'm not including start less than equal to end? Because remember, start and end are basically two separate subarrays, okay. Because the last element of start should be compared with the first element of end, okay. That's why I'm not writing the equal to sign here, as simple as that, okay. So what I have to do, just ignore this part for now, we'll come to this. But what I have to do, see this part, if array of start plus 1, that is for the current element, if the next element is greater, then I'm going to start plus 1, okay. For the current element, if the next element is greater than my current element, then I'm going to do start plus 1, otherwise I'm going to break, okay. So before that, before doing this part, what I'm doing, see, for the current element itself, I'm checking, see what element needs to be removed from my right subarray, so that I can merge the left subarray with the right subarray, okay. That's what is done in this part, okay. What element needs to be removed from the right subarray, so that it can be merged with the left subarray, okay. That is what is done with this part. So what I'm checking that the rightmost element in my left subarray, okay, that is the rightmost element in my left subarray should not be greater than the leftmost element in my right subarray, okay. If you see here, basically this is what is happening. Yeah, this is what it is. See, now I have 1 and 2 here. Okay, I have 1 and 2. But previously, what is my right subarray? This is this. Okay, so what I'm comparing, I'm ensuring that every element in the right subarray has to be greater than 2. Okay, either equal to 2 or greater than 2. Okay, so that's why this 1 needs to be removed. So that is what I'm doing here currently. Okay, so basically, I'm ensuring that whenever array of start is greater than the area of end, okay, so I have to move this end. Okay, why I'm moving this end? Because the area of end is smaller than compared to my this element. Okay, so I have to remove this element so that a bigger element comes to this place, okay. This I have to do till which time? Till end is less than n, okay. By less than n, again, if you see here, basically you're doing n plus 1, okay. That's the reason why after n minus 1 it will become an and will become as n, okay, in the worst case. So it will happen. Then what I'm doing, I'm calculating the sub array that is between the start and the end. What is the array that can be removed? Okay, that is what I'm calculating here. If you see why this formula is coming, have to imagine this basically. So see here, let us say it is 235 here, okay, 235, and it is 1 here in this case, okay, 1. So basically this is the array to be removed, right? So if you have to understand this, so where is end is here, right? And where is start is here. So if you do end minus start, basically you are going to get this whole array, but we are doing minus and 5 because we should not remove 2 also, okay? So you have to remove only this part. So that is why I'm doing a minus 1 here, okay? And minus start minus 1. Then this part I already explained. You have to keep moving the start. If you are not able to move, that means you have to break out of the loop. And finally, I'm returning the answer. So let me run this again, and yeah, it works. Yeah, if you can see, it works. Okay, so this is all about Python solution. Okay, here we did not use anything much here, but it's only about the approach. Okay, it's the 2-point approach. It's only about the approach. We are not using any complicated data structure here, basically. Okay, no sorting, nothing happening. Okay, next let us go to the Java solution. If you see in the Java solution, we are doing exactly same thing. Okay, exactly same thing. What we are doing, we are taking the n, okay, array of length. We're declaring the first pointer, which is n minus 1. We are making it run till we get, for example, this array. Okay, 235. That is in the right most part. If I start, how big array I can get, which is non-decreasing. Okay, so this is what it is. After that, end will come in to a halt. Okay, then I'm resetting the probable answer, so that is if 235 is my right sub array, and then this particular part I can remove ultimately. Okay, so at the starting I can think of that. Okay, I have to come to a rough answer, right, from where I can start optimizing it. Okay, so this is going to be a rough answer, that if I remove the left part, I still have a non-decreasing sub array. Okay, at the right, this part. So that's why I'm starting my answer with end. Okay, then I'm declaring the second pointer, this while loop until start is less than end. And yeah, this is what is happening. So the start pointer will keep moving like this. Okay, for each movement of start, we are again doing this to ensure that the left and the right subarray could be merged. Okay, finally when we are coming after this particular while loop, we are returning the answer. So let me run this Java code also once. This also I've segmented basically, and it got accepted. So yeah, this is also clearing all the test cases. This case for basically I can give you in the comment section. You can include this, because if you see there are double threes here, so this ensures that your solution is optimal. That is, your solution takes every test case, only then this will get cleared. Okay, this is one of the last test cases. If you can clear this, you can be sure that your solution will be accepted. Okay, so yeah, that was all about it. And one more thing here is, see here, it is positive. Okay, that's why this solution worked. If it is so, otherwise, see, if numbers start becoming negative, then problem will come with math.min. Okay, what will happen, you will take the minimum one. Okay, that is what it is. So that's why we have to always ensure that you understand whether the answer is going to negative or positive. If it is negative, you have to use some special if conditions to understand, that is to handle each scenario. That is what it is. Okay, so that's why this solution becomes slightly easier, because we have this particular constraint that numbers are going to be positive or zero. Okay, so often that was all for today. In this, I don't have anything much to show you, like which you can learn. The code will look simple, but it's all about the logic that you are trying to build. Okay, this, if you talk about the time complexity, it's going to O of n by. See, at max, what can happen? See, start can go till the end. That is what it max can happen. And see, this can end can go till the start. Start can go till the end. Okay, those are only the two things, right? So what max can happen in that? So yeah, O of n only, right? Both of them can go from that is whole iteration of the loop. Okay, whole iteration of the array. So that still it remains O of n only. And if you talk about the space complexity, we are not using any extra space here, if you see. Okay, so it will remain open, and it remains the same for both Python and Java, because we are not using any data structure as such here in both the solutions. We're doing simple while loops and simple if conditions only, right? So this remains the same. Both the time complexity of both solutions remains the same. So yeah, fine, that was all for today. This question was slightly on the trickier side, but yeah, I feel like, see, there could be multiple ways to solve this, because this question, uh, see, there can be edge cases like this. If you see, this is like totally decreasing, so the answer here is you have to remove only one element, and you have to remove all the other elements. So yeah, those edge cases are there, but the thing is, like, there is so much to explore here. Okay, if this comes in a face-to-face interview, there is so much for you to explain and so much for you to show to the interviewer. That's what I felt, this question could be good when it comes to a face-to-face interview, because there is so much to learn and so much to explain. Okay, so much to explore in this. So yeah, and that was all for today. If you like my efforts, please do subscribe to the channel. It really gives a lot of motivation to continue further. This is actually day 15. We have around almost half of the month is over now. We have around 15 days to go. If you have continued till here, please maintain the same momentum. This will really give you a big result in the long run. Okay. So see you tomorrow. Thanks a lot.